Hello, everyone. I'm Sydney Shepard, editor of Occupational Health and Safety magazine. Welcome to this live one-hour webinar all about how Xcel Energy built an Arc Flash electrical safety program. Our webinar today is sponsored by Perficient. We have two speakers for today's event. The first is Eduardo Ramirez-Bettoni. Eduardo is an electrical engineer with over 20 years of international experience in the design, construction, commissioning, and maintenance of electrical utility substations. He works as a principal engineer in the Transmission and Substation Standards Department at Xcel Energy. Our second speaker today is Morgan McNeal. Morgan is a senior product manager with more than 15 years of experience in project and change management, process analysis and improvement, supply chain operations and optimization, and ERP implementation. She is currently a senior project manager with Perficient, where she supports energy clients in standing up and revitalizing their safety programs. Before we get started, I do want to address a few housekeeping items. At the end of the presentation, there will be a Q&A session where I will ask our speakers a few questions from you. If you would like to submit a question, you are more than welcome to use the Ask a Question console on your screen at any point during the webinar. If you have any technical difficulties during the presentation, click on the Help button located below the slide window and you will receive technical assistance. And finally, after this virtual event today, a link to an archived version of the webinar will be emailed to you so that you can view it again or share it with a colleague. I want to give one more special thank you to our sponsor for their support of this webinar, and also to Eduardo and Morgan for presenting our audience with this very important information. And now I'll turn things over to you, Morgan.
Thank you, Sydney. Hello, everyone. As Sydney said, my name is Morgan McNeal. I am currently a senior project manager with Perficient. Just to give some high-level information on Perficient in case you are unfamiliar with the company, we are a leading global digital consultancy with extensive strategy and technology capabilities. We have numerous locations across the U.S. and Europe. We were founded in 1997, and we are a publicly traded company on the NASDAQ. We have approximately 6,500 employees, and we have extensive strategic partnerships with major technology vendors and also have dedicated solution and industry practices. I am specifically in our management consulting group, and I've been working with Eduardo at Xcel Energy for a little less than 3 years. My primary project has been assisting Eduardo with standing up a safety program focused on arc flash hazards within the transmission business unit. My background is in engineering, but not in electrical engineering, and certainly not in arc flash. I didn't actually even know what a real arc flash was until I was put on the Xcel project. When I found out that I was going to be going to the Xcel account, I spent about 3 hours watching some YouTube videos to try and figure out what my new project was going to be about. After I watched those videos, there was one question that I had for myself, and that was, what in the world am I getting myself into? So what is an arc flash? So an arc flash is basically where a flashover of electric current doesn't follow its intended path and travels through the air from one conductor to another or to the ground. An arc flash event can have explosions, flying debris, it can be very loud, cause fires. If there's a human involved, extensive burns. And if that human is depending on the energy of the arc flash, there's a high likelihood of injury or death. And although Eduardo and I are going to be talking specifically about the electrical safety arc flash program that we implemented at Xcel, a lot of the activities that we're going to discuss today are going to be the same when setting up a variety of different safety programs. So having a manager sponsor, documenting a change management plan, conducting a gap and system analysis, and ultimately learning from the process and what works and what doesn't. And so now I'm going to turn it over to Eduardo, and he's going to discuss why it's important to set up an arc flash safety program and provide you some statistics.
Thank you, Morgan. And welcome everyone for the webinar. I appreciate your attendance. Really quick, I work for Xcel Energy. Xcel Energy is a electric utility and gas utility in the United States. We operate in 8 states in the mid-USA, and I run special projects as part of the standards department. I'm also secretary of the ASTM F1865 subcommittee on protection from electrical hazards, co-convener of IEC Working Group 15 of TC78, and member of multiple standards that are related to worker protection. Let's talk about arc flash statistics. Before kicking out the webinar, Morgan and I, we wanted to show how much of life-changing events arcs could be. So in this case, these are some basic statistics. I'll warn you that depending on what source you consult, they vary. I guess they get at least the main message. So the numbers, again, they are multiple studies, and there's some variability. Let's start with the first one. It says that 5 to 10 arc flash events happen every day in the United States. So there was a study provided by Kowalski and Barrett from 2007. Some people may argue that the numbers could be as high as 10 times this. What this shows is that arcs are still really frequent. They occur in the workplace, and that could be because of people doing the right thing, and the equipment just happens to have issues, but also people, let's say, having some issues or needs with how they perform the work, or how the tools are inspected, and how the equipment is operated. Moving forward, there's another very good study performed by Dawn and Hoagland from 2010 that says that as part of 40 events with 54 workers involved and injured, 2/3 of the lot failed to conduct an arc flash analysis for selecting PPE. We wanted to show this statistic just to show some of the reality that is happening out there in the industry. And basically the importance of why it is good to have an arc flash program that is active and sustainable. And especially that the communication goes to the employee. Nothing works on paper unless people are aware of the message, the procedures, and the training. So it's good to have people have the conversation on that. And finally, there are many studies that have some sort of agreement about 3/4 of electrical worker fatalities and injuries are caused to burns, not electric shock. So this is an example from the database of the Bureau of Labor Statistics in the U.S., and there's some other examples of studies. In this case, there's a medic study by Buja from 2010 that shows more or less about that range. So as you can see, arc flash has a significant impact on the thermal protection of the workers. For those who are more interested in getting some other good sources, they can reach out to Morgan and me after the webinar. Also, I recommend people to look into NFPA has some good studies, and the one cited below, occupational injuries from electrical shock and arc flash events is a very good one. Now we're going to move forward and cover the main aspects that work for us in terms of establishing an arc flash safety program. In my case, I work for one of the business units in Xcel. However, I form part of many corporate groups that look into electrical safety across the enterprise. I work for the transmission business unit, but this program started in our business unit, and it got exported to the entire corporate. So we're going to go through different stages during this webinar, including the importance of management and sponsorship, change management, gap analysis, system analysis, and evaluation of the work methods. One thing that is very important regarding the sponsorship of management is that any project starts with an idea, and it's very important on how you sell that idea. So in this case, Morgan has been a very good partner that I had for the last few years. However, how do I get access to resources such as Morgan and other people that have been part of this multi-year effort, and especially multidisciplinary? And we have been reaching out to literally thousands of people. Well, one thing that is very important is that any program that has the commitment from upper management has very good success. So how do you gain that? One thing that we recommend, Morgan and I, we wanted to bring up to everyone, is the importance of that communication with upper management and presenting the difference between the current state in which the company is operating versus the desired state. It is good to identify in a business case if there is any procedural gap or if the company is impacted by a new regulation or both. It is good to give examples on how this affects the multiple departments and bring up some statistics or some, let's say, real data, statements from employees, examples of incidents, and so on. It's good to bring a picture of what resources are needed. Of course, this is a business case stage. You should aim to some picture of how you see this being implemented. If I go back years ago when I started doing this in 2017, I'll probably build the case different, and hence that's why we wanted to show this webinar to you all. Management will always ask, what is the estimated cost? So it's good to have some estimates. And a good strategy, I work for an electric utility. It's good to have some capital plan. So see how much expenditure could be implemented in capital funding rather than using O&M, as in operation and maintenance funding, and see if there's any opportunities to maximize the capitalization of the expenses. And then finally, it's good to come with a change management. It takes the worry away from upper management if they know how you are going to implement the different stages and how people will take this. Arc Flash has a very human component. Humans react different to change. So it's good to organize town halls, see how the communication is going to go, a training plan, and so on. Now I'm going to move over to Morgan, so she continues with the change management.
Sure. So when I joined the Xcel team, Eduardo had already done a ton of work getting the management sponsors, buy-in. So what I needed to do was look forward and see how we were going to implement this pretty big change to such a large organization, hence our change management plan. A change management plan doesn't really have a start and a finish, and I would say it's continually evolving. But basically, it's preparing for the change, managing the change, and then reinforcing that change. The approach that we took at Xcel was pretty robust. Probably why now whenever anyone in the entire Xcel organization has a question about Arc Flash, they come to Eduardo and me. That's not to say that Eduardo and I know everything there is to know about Arc Flash, but in the cases where people would come to us with questions, if we didn't know the answers, our employees knew that we cared enough about them to find the answer and follow up with them. The most important thing that I would say in this whole program is communicate, and then communicate, and then communicate some more. What we did was we sent out numerous e-bulletins announcing the change. We held town halls to announce the change. We held town halls to follow up on the change. We also developed training content that was catered to the type of worker. For Xcel, it was if they were electrically qualified or not. We organized in-person training sessions for over 2,000 people across Minnesota, Colorado, and also Texas. we worked with our internal video production team to produce videos explaining Arc Flash to our employees. I can say that I never thought that I was going to be a video producer, but I'm going to add that to my resume now because we went through the whole process of creating videos and writing scripts, and we had a script writer, and we had to get models for our videos. So definitely not something that I thought we would be doing, but we did. We also made all of the materials that we created available on our intranet page, so employees knew exactly where to go to find information, and it wasn't hidden in some database somewhere. We created an email address in which employees could submit questions regarding Arc Flash, and from those questions we received, we created an FAQ document that, again, was placed on that intranet page for employees to reference. We did so many things so we could prepare our workers for the change, manage the change, and ultimately reinforce the change. But I would say that for change management, it was most important to make sure that the workforce was set up for success. To ensure we were creating a good Arc Flash safety program, we needed to know where we were and where we needed to go, and that's where the gap analysis came in. And Eduardo, with that, I'm going to turn it over to you.
Thank you, Morgan. So let's say at this point, we have already submitted a business plan with management and they got approved. So now you have a team and you are kicking off within the next few months. There's got to be a stage in which you're doing the so-called gap analysis. So we're going to see and evaluate how far the company is from the desired point. So you have the team assembled and do a regulatory review. Morgan and I, we wanted to show some of the significant regulations from the Occupational Safety and Health Administration, OSHA, that impacted us. Quite honestly, we had to put a complete list of regulations. I'll probably fill 2 slides. So for those who are interested, they can reach out to us, later. We just wanted to show some of the significant ones. After several hundred pages of good reading, it's good to have the opinion of different individuals, hopefully with different backgrounds, as people, it's human nature, and also the way the regulations are written, they may be up to some interpretation. So there's a stage that takes some time. As a parallel activity, it's good to review also the company practices. And this is very interesting because there's something that I learned as I was going through. As I explained before, I'm an electrical engineer, but I had to try to crack out of that, mentality, the engineering mentality, and try to have like a more hands-on point of view. And I realized that when you're talking about company practices, there are written company practices, there are spoken company practices, and there's also the ones that the people use in the field, whether they're written or transferred through word of mouth. So as we were reviewing that, we tried to encompass all of that. So the fact that a policy is uploaded in the system, it doesn't mean necessarily that people are communicating it properly or it's being transferred through training and field implementation. We found some gaps. We identified them. Also, we realized that Arc Flash, and this is something that I want to warn everyone, when you have a topic of interest that you're trying to resolve, sometimes you set up the blinders and you continue with a tunnel vision. That's something that in the first stages, a good friend of mine, Marsha Elan, she recommended me to look into the bigger picture. And at the end, this is all electrical safety, right? So as you're evaluating Arc Flash, it's good to take a look into other aspects of an electrical safety program, because Arc Flash impacts, they all impact each other. So one is the MAD, or minimum approach distances, personal grounding, lockout tagout, also known as LADO, and work methods and the like. As part of that, there's a moment in which you have an idea on how things are working. Well, we wanted to communicate to you that it's good to have a stage called field observations, in which you take a plane or a car. In this case, Morgan and I, we did both. In 2019, I flew the equivalent of 50,000 miles trying to enact, everything that we needed. Xcel is spread out throughout the U.S. And we went and talked to the field guys, phone calls, in person, and so on. And we realized that there were some gaps in which the part of what was the perceived action that the field guys were supposed to follow, there was, some differences in practices, which is, part of the human nature. So we took note of that. We also, as we were conducting the interviews and doing these reviews with the departments, we realized also that PPE was good to be standardized to some extent. And we were seeing, the way people were wearing or procuring, the PPE, personal protective equipment, and we took note of that. In addition to that, we determined that it was good to create two bodies for continuing with the effort. So I requested the permission from upper management to create two technical committees. One was made out of engineers and the other one made out of field folks. And we call them the Arc Flash Technical Committee and the Arc Flash Field Operations Task Force. And that seemed to work pretty well and have the two committees communicate with each other. Now I'm going to pass on to Morgan for implementation and resources.
Sure. So Eduardo and I identified the gaps through the regulatory review and the review of company policies and procedures. Our next step was to develop the implementation plan. So what did we now need to do after identifying the gaps? So we identified that we needed to develop a field manual, which would explain to workers when an arc flash hazard existed, give them examples of common work tasks, and if there was an arc flash hazard for that particular work task, how to handle the hazard, what personal protective equipment or PPE would be needed, how to purchase the PPE, and then we also needed to train all those affected workers on all of that. So once we figured out what we needed to implement, we needed to find some people to help us. Those people were people from other business units within Xcel. So our legal department, our safety department, technical training department. We did a lot of train the trainer sessions because when you're trying to train 2,000 people, Eduardo and I, although we flew a lot, it was not possible for us to cover all of those trainings. So it was really important for us to coordinate with internal business units. We also partnered with some of our peer utilities to ask how they set up and ran their Arc Flash program. A lot of the advice we used, but I will say that you kind of need to know your business, know your field guys, which is where the field observations and field meetings came in handy. But it was very important for us to know what would work for us. And the other thing that we did was we attended industry trainings to make sure that the program that we were going to try to implement was going to keep our employees safe. So we had a plan. We knew we needed some help, and that was more than just me. So I'm going to give it back to Eduardo to talk about our methods.
Thank you, Morgan. And one clarification that I wanted to say is that Xcel Energy, we're around 9,000 employees spread out in 8 states, and we have about 2,000 to 3,000 contractors that work for us, depending on what time of the year you see, depending on the influx of projects. Our transmission, we have 2,800 individuals, and 800 individuals are called consultants, contractors, and then we have 2,000, let's say, affected employees by the program. So it could be people from the field, like electricians, linemen, civil workers, field engineering, engineering department, because they go out to the field and they interact with equipment, project managers, and so on. Okay, so at this point, we have created the program has some maturity. Let's say it went from its infancy, and there's a lot going on. In this moment, it is good to do some system analysis and come up with a methodology, because as you are trying to implement now, your program is going to branch out. And Morgan and I and our team at this point, we started finding out with multiple committees, multiple teams, and outside partners. So in this case, for the data collection, just to give you an idea, Xcel Energy, we own 1,700 substations. We have 85 power plants. We have 16 gas transmission processing facilities. We got 2 nuclear plants. We have 2,500 transmission lines, 69,000 volts and above, and we have thousands of feeders. So as you can tell, it's good to have some organization. We conducted a review of all the assets owned with the asset management department. We also reviewed available software and engineering tools that we could use to store that information and analyze it. And then we went through sampling some of the assets. We were checking engineering drawings, GIS database, and so on, so we can identify some commonality. And turns out there is some that will help you later down the process. So after you have reviewed hundreds of substations, you start seeing a pattern, and then you can find some ways in which you can crack down the estimations and work methods and so on. In the calculations and assumptions step, it is really important to know that arc flash is not about sniper rifle job. Is more like a grenade and big explosive work, because there's not that much precision. The calculation and estimation of the work methods, the estimation of arc flash energy, it varies a lot. Constantly there is development and research on that. There are some really, really good documents out there. I think everyone is aware of IEEE 1584 for systems, electrical systems rated 15,000 volts and less. There's also some very good EPRI technical reports, NFPA 70E, and some other codes out there, the National Electrical Safety Code 2. The one thing is that there's not one method that fits all of them, and you're going to end up having a variety depending on the type of system and the type of energy that is stored. As part of that, we conducted some preliminary studies in which we were calculating fault current. For those who are not familiar with electricity, arc flash is dependent on many aspects, but one of them is like the strength of the system. So when the electricity goes through a path that is unintended, it will flow, and that we call electrical current. Then if we have a measure of that and the time that it takes to extinguish that event, we have an idea of the energy of the arc, as it could be imprinted to a person. So we came up with some charts, tried to put types of equipment into buckets and so on. We had a better idea on how to tackle, how we're going to analyze this group of assets. In reality, we have hundreds of thousands of assets. So we developed an engineering guide for calculating arc flash. There had to be some agreement. I think that took Morgan and I about 18 months to come up with the first release standard. It was really easy to get outside partners. Our system protection engineering department started with us. However, that's not their main activity, was to look into arc flash because they do system analysis for protective devices, but they were a good place to start with. And we ended up with outside consultants. We needed to give a one message to everyone. Now, one thing that is important is that all the calculations need to be peer-reviewed. That is, a lot of the engineering boards in the United States call out for the need for peer-reviewed calculations. So we had to put that in place. Now, for data storage and presentation, we have to go and create different ways to convey the information that was one once we had the energy of the arcs calculated for different work methods and distances between the worker and the live parts, we have to put it in a template that people could understand in the field. It turns out that engineers and field folks, they talk about the same stuff, but they don't cover the same amount of details. There are some topics of interest that they're not common to each group. So it was necessary to have end client-focused mentality. So in that case, Morgan and I and the rest of the team, we were able to meet with the field folks and tell them what was the format, what was information that was relevant for them and what had to be just kept in the engineering studies. So we created a spreadsheet for general system conditions. For those who are familiar with live work and the energized work, for the energized work, we put grounding devices. So we disconnect the lines and then we ground them, connect jumpers to ground. And in that case, it is typical to assume that the system is energized until you determine that it's not, right? So it's been known in the past that people apply grounds on equipment while it's energized. So you need to use the arc flash values for that. So those first level of protection of tables, it assumes the system intact and ready for disconnection. And people will take that pretty often from the construction projects. Then we put a second layer. It's called site-specific studies. And in that case, we recognize specific states of the electrical equipment in which it is typical to projects or different maintenance activities in which there's going to be some further examination. And in that case, in terms of going out and doing all the permutations, we created a system in which there is an end user, there's a form, and there's a process in which they can request system protection engineering for a specific incident energy or energy of the arc. Examples are when you're paralleling transformers, the current goes up. So sometimes that may turn into higher energy, thermal energy of the arc. Another one that we had is when people turn off protection relay schemes because they're either damaged or they need to be replaced. An example is the replacement of a bus differential relay. In layman terms, it's just that if there's a fault in that piece of equipment, let's say the equipment that is supposed to disconnect it is not available. So there's got to be some equipment in the vicinity that will have a delay because that's how we coordinate the systems anyway. And that may increase the arc energy. So people could request those site-specific studies. Finally, we collected enough feedback from the field personnel. I would say Morgan and I, we tried probably like 10 times, to create tables and then come back and change the format over and over again until it was acceptable. We're doing another review now, and as part of that, we're trying to make our program live and be sustainable. So we're reviewing it on some cycles. We implemented fully 3 years ago, and now we're doing another review that we're currently conducting. Now I'm going to pass on to Morgan so she can discuss some of the timeline and resources.
Yes, thank you. So as Eduardo was talking about our methods on doing our data calculations and getting our spreadsheets out to the field with the information that they needed, we did set up a timeline. I might offend some of my utility friends on the webinar, but I'm going to say it anyway. I've noticed that some things take a bit longer in the utility world than what I'm used to. So I say that to say that you have to have a timeline, but it also has to be flexible. There were tasks that I thought would be quick and easy, such as when we decided on a software, giving that software to all the folks that needed it. It wasn't that easy, and it's understandable that there's systems in place, and we needed to follow the process to get the appropriate licenses. But what that did was push out some of our other tasks. So we had to be flexible. We had to prioritize. As Eduardo said, we did have a process for doing site-specific studies in which the specific configuration of a site was taken into account, but we also had general assumptions, which allowed us to calculate the necessary incident energies for what we needed to. We learned early on that we needed to build buffers in our timeline. We were depending on others, so system protection engineering was helping us with the calculations and the general assumptions document, but helping us with our arc flash calculations wasn't their primary job. So they had to juggle all of it, and we had to juggle all of it. But in the end, we did make it work. We did our arc flash incident energy calculations for all of our substations and transmission lines, and we were able to document our work methods. So Eduardo, do you want to talk a little bit about the work methods that we established?
Thank you, Morgan. Well, at this point, you have some estimates of energy of the arc. Well, it turns out, I know that there's many people out there that offer services on producing all these studies, and they're really helpful, but they're only like a starting point. At this point in the slides, I think that you have definitely gone through a third of the overall effort. And this is what the study is on the table, right? At some point, there's got to be a lot of work, legwork, doing analysis of what are people really using, what tools they're using, what are the sequences of connection, disconnection of devices, and so on. So work methods, what keeps people safe is the work methods. And good training, repetition, demonstration of capabilities, hazard analysis, tailgate discussions prior to work and after every break. So if you see on the right, there's a hierarchy of risk control methods. This is a concept that initiated in Europe a few years ago, and then it was imported to the United States through the NFPA 70E. And it has a good approach in which you start with an evaluation on hazards present, the risk, or in that case, how much they can occur, and then how intensive they are in terms of potential to produce harm. After you do that analysis, then you start with an initial risk and hazard level, and then you try to reduce it as you're applying different techniques or control methods. Finally, when you get the residual risk and hazard, you need to come up with a PPE strategy and decide if you're gonna, how much you're gonna accumulate there. So as you go from top to bottom in the pyramid, you see it's an inverted pyramid. The elimination is known to be a very effective method to control arc energy. Sometimes a typical example is disconnection. And during disconnection, you can, let's say, work good, right? Because the sources are removed, system is grounded, for example, or isolated, and there's no comfort level. Now, that has an impact on customer service, because there are some lines that if we disconnect, they may not be conducive to people having electricity flow to their homes and factories and so on, offices. So in that case, sometimes the electric utilities need to make some determination, and we have crews that they perform live work. So in that case, the system is energized, and you see some of our linemen in the streets performing with some special gloves and face shields and some other protection and equipment work on systems that are live. So elimination is good, a good strategy, but it doesn't work all the time. Based on that, the next in level down is the substitution, in which you are changing the amount of energy by changing some aspects on how the work is conducted. So in that case, for example, you could use some, for people who do hot sticking, you can add some of the distances for the hot sticks. And in that case, if you're adding a buffer in between the work and the equipment, the arc energy tends to go down because of how the energy gets dissipated with distance. Furthermore, there are some engineering controls. There's some equipment that is built as is to protect workers. There's been a lot of development in engineering controls. There's interlocking. There's barriers that come with the new equipment. There's more equipment that is arc flash resistance or that it can be racked remotely and so on. However, utilities like mine, we have been in operation for the last 100 years at least. So there are some sites that they didn't have this philosophy. Again, that could be implemented at different levels or limitations. Another one that is typical for engineering controls is to have protection settings that somebody, before performing work, they change how fast the system disconnects and lower the arc energy. Administrative controls, and this is very interesting because a program like the one that Morgan and I and our team was putting together for Xcel, it has a paper trail, right? And also we're writing procedures and everything, all those discussions are being put together in terms of paperwork. But then that paperwork is not as impactful unless people know that it exists. So administrative controls shock some people, but actually they have a low effect on safety workers unless you are constantly communicating and training and having people have those discussions. Finally, PPE is the last line of defense. We created an arc flash field manual for the company that has care, use, and maintenance of clothing that is arc resistant and flame resistant. We also tied in the good work methods with work tests and associated arc flash hazards, and we communicated the arc flash tables in different platforms. Right now, we're doing a lot of job safety analysis for the workers, and we also developed some of the clothing catalogs for the company. Now, one thing that was interesting and I enjoyed about the interaction was to perform meaningful evaluations for the company, and I decided to put the engineer back hat on and then hire a couple of laboratories who've been doing analysis of failed equipment. And also what you see up in the screen is part also of some of my work with ASTM International in standardizing and putting some equipment, personal protective equipment, to the test in the laboratory. And Xcel transmission, we have some company spec in which we double check that the products are meeting the expectations of the standards. On the left side, you see some of the typical exposures with mannequins, and we dress them same as our workers. And then on the right, you see some evaluation on some new products in terms of head protection and some special rainwear solutions. Now I'm going to pass on to Morgan so she wraps up with some of our lessons learned and final thoughts. Thank you.
Thanks. So I would definitely say that Eduardo and I have learned a ton as we stood up this Arc Flash program. I, for one, learned that I like to see stuff blow up. But in all reality, we learned the importance of our manager sponsors who trusted us, and when we said we needed something, did their best to get it for us. We learned that the Arc Flash program wasn't built in a silo, and it touches so many other things like Eduardo mentioned, our temporary protective grounding, our lockout tagout program, our minimum approach distance. And I'm hoping that Eduardo likes working with me because I think we've identified probably another 5 years plus worth of work to get all those policies and procedures updated. Another lesson we learned and are still learning is that the program, once set up, has to be sustainable. Some people like to ask what would happen if Eduardo or I got hit by a bus. I like to ask what would happen if we won the Powerball. Would this program continue? So to ensure that, we learned that we had to bring in the appropriate groups. Specifically, our enterprise learning organization helps us to create a web-based training module. We also created a schedule for when our Arc Flash studies should be reviewed and by whom. Currently, our Arc Flash Technical Committee is reviewing the calculations, and also we're leveraging the Arc Flash Field Committee to review the field manual and make the appropriate changes. And lastly, I would say, if I haven't said it enough, communicate, and then communicate some more. This will show the affected employees that you're willing to listen to all of their concerns. But, and this is a big but, this Arc Flash safety program that Eduardo and I set up was successful because at the end of the day, our infected employees knew that we cared about their safety and ultimately that we wanted them to return home safely to their families every single day. Thank you.
Perfect. Well, thank you both so much for that great presentation. We do have a couple of questions here that I'd like to ask, but wanted to remind those listening in that they can ask a question using the Ask a Question console on their screen at any point for the rest of the webinar. We are going to try to get to as many as we can. So the first question I have, I'll direct it to you, Eduardo, is how did you grow this program from transmission to the rest of the organization?
Thank you. I appreciate the question. Quite honestly, all these programs somebody has to start it, right? In my company, it just happened to be me and some small group that we were just curious enough to start finding some improvements as part of our business unit. So we started with something small. I guess the one thing that it helped is when I presented the business case to upper management. Upper management in Xcel communicates with all our business units. So it really took about 6 months, and from what started as a small project to make some improvements in transmission, it captured the attention from multiple vice presidents in the business unit and up to the CEO. And CEO made it a goal for the end of the year and for the upcoming years. So I guess it was part of some of the commitment to, make the improvement. The workers, while it was being analyzed, the upper management reviewed with the field workers, and it just turned into a large effort. So I recommend everyone always to try to advertise these projects, but I feel lucky and grateful that it became a corporate endeavor. Thank you.
Absolutely. Morgan, do you have anything you'd like to add to that one?
Yeah. So one of the things that's come up on the corporate electrical safety committee that's been set up that has all the business units, and we're focused on Arc Flash. I think our chief of staff said it best, and she said that there's going to be leaders and there's going to be followers. And transmission was definitely a leader in the organization. We worked through setting up this program, and then it allowed the other business units to follow some of the things that we were doing. I would always laugh when Eduardo, if another business unit was struggling, would say, "Oh, well, we can get you a Perficient resource to help you," because that was one of the reasons that he was able to set up his program.
Great. Moving right along here, we do have another question. Eduardo, I will point this one in your direction again. It says, do you require a minimum level of Arc Rated PPE to be worn by electrical workers all of the time?
Thank you. That's a really interesting question because the company, I think we're still evolving to have an answer to that. So the good part of it is that, at least in my business unit, I perform an Arc Flash study of the energies of all the assets. So I came up with some statistics, and it turns out that if you see the PPE categories as explained in NSTS 7E and some other codes, there's a big jump. It goes 4 calories, 8 calories, and then it jumps to 25. And I always had the idea that, well, there seems to be a big gap, going from the 8 calories to the 25. So in my case, I was able to justify a double system for, we call it standard issue PPE of 8 and 12. So we came up with a justification that it was something about 96 or 97% of the assets could be covered with a 12-calorie system. So when we issued that for electrical workers, that could be, they didn't need to get a second issue of PPE. And then we cut down the 25-calorie category, and then we just made it a 140-calorie category after that. And that turned to work a lot for the electrical workers. Then there were some other categories of workers that they're less affected, that they're not performing live work, and we put them in a PPE hazard category 2 of 8 calories. That's transmission nowadays. One thing that I'm working is in layering. So we have the opportunity to give to those folks that have the 12 calories to put a coverall on, and that's something that I hope to get approved within the next 12 months. And we can bump up the protection up to somewhere in between 20 to 30 calories, and that cuts down furthermore the need of use of arc flash suits, which is funny to me to say because I'm actually the chair in ASTM of the new standard on arc flash suits that I wanted to advertise really quickly. So yes, ASTM is going to come up within the next 2 years with an arc flash standard specification on arc flash suits. But again, the intent is to have people wear comfortably their PPE. Our business units have different discussions, like in Xcel Energy, energy supply has a 12-calorie and a 40-calorie system. Distribution, so this is for feeders, they use an 8-calorie, and they use coveralls or some extra protection over that. So I think we have a couple of currents of thought, but hopefully we can harmonize in the future. I hope I answered that question. Thank you.
Yes, I think you did. Thank you so much for all of that. Our next question I have here says, can you expand on some of the gap safety measures that were implemented? And they're also asking, what are some examples of measures taken when equipment is not considered operating under normal conditions per NFPA 70E?
Thank you. Can you repeat I'll do it I will turn it into a double question. Can you repeat the first part, please?
Yeah, of course. The first one says, can you expand on some of the gap safety measures that were implemented?
Yes. So one thing that we looked into was tools and methods. So for tools, we are revamping our strategy on use of live tools and using the right live tools. So we're looking into evaluation of hot sticks, evaluation of voltmeters. We also have, like, for example, one group that I started with, it was for light work on extra high voltage systems. So we did a complete evaluation on use of metallic suits. I'm actually the chair in ASTM for the metallic suit standard specification for light work. We got the workers new metallic suits, and we reviewed some of those methods. We got arc protection and flame resistance in them. For the rest, I would say we've been evaluating, like, remote racking systems is a good one to implement. Try to remove the person from the equipment. We have a lot of equipment that is existing that it was not built or designed accommodating ARC, because ARC, relatively has been recent in the industry compared to what we installed. So we've been analyzing types of equipment that tend to fail more and kind of like give some warnings about that. Another one that was a big one was the fall protection program, and then make sure that everyone had ARC tested harnesses. Right now I'm conducting a light rope, and I'm actually the chair in ASTM for the light work rope standard. And I can continue with a longer list, so probably I could continue with more time. Maybe if the person can reach out to me, I can give more details. What was the second part of the question?
Absolutely, yes. The second part of the question said, what are some examples of measures taken when equipment is not considered operating under normal condition per NFPA 70E?
Yes, so that's something really important that is brought up as part of the newer version of 70E. the status of the equipment, it changes throughout the maintenance. I think it's very realistic to assume that. So depending on how you are performing, the equipment could be damaged or prone to failure or show some signs of impending failure prior to when you started the task, or it can happen throughout that. So one thing that we identified in our Arc Flash field program, which has a manual, is to identify that the workers need to be aware of the changes of state. In our case, my company is an electric utility, so we take some exceptions from 70E, but we take some of the core values, and that was one of them. So what we call is there's like an interim process in which you realize that the activities changed, the hazard level went up, and then people are instructed to stop work, like go back from the equipment and then kind of rethink and then do a reassessment. In that case, people may change their work methods. So sometimes, for example, if I am working on a circuit breaker, so I'm going to make some references to substation equipment. There is some equipment that requires a special gas called sulfur X fluoride to extinguish arcs, just as part of the normal operation of the system. If you're going and checking, we instruct people to check the alarms. If the system has critical alarms, they're instructed not to perform the work as needed. So sometimes they need to do the complete de-energization of the system. And I went through a long period of time in which we had to meet with controls and operations. So when crews were talking to them, we were explaining what the reasons were of why you need to do the energizations. Utilities like mine, we're allocated for in emergency situations to be able to disconnect the service without affecting some of our, let's say, statistics for operations. And that was something that we got really clear. There are some other cases in which, for example, cable splicing is a typical one, in which you can use arc suppression blankets. When people are performing work on splicing, because sometimes you de-energize a cable, but the adjacent cables, they may flash because of the vibration. Another one that is typical that we had is we had a couple of projects in which we were replacing metal clad switchgear, and there were adjacent equipment, and we had to drill hammer, and this was in some basements, we had to drill hammer some of the existing infrastructure to reroute cables. Well, that may cause failures, so you try to do some isolation. So you have your circuit is disconnected, but now you need to see stuff that is in your vicinity and go on. So that's I invite everyone to check out the newest edition of NFPA 70E, and there's some good examples in the appendix. I can go farther. If I would ask the person to reach out to me via email, and I can give some more feedback on that. Thank you.
Definitely. Thank you both so much. We are getting down to the last final minutes of our presentation today. So I wanted to make sure you both knew that we appreciated all of the information that you gave us. I would also like to thank Perficient for sponsoring this webinar, and also a special thank you to all of you who listened in and participated with us today. Remember, in the next day or two, we will be emailing you a link to the archived version of this webinar so that you can view it again or share it with a colleague. Thank you so much for attending today's webinar. This ends today's information session.